Welcome to our comprehensive tutorial on debugging in Visual Studio Code. Today, we're diving deep into the powerful debugging features of VS Code. This tutorial is aimed at both beginners and experienced developers eager to enhance their debugging skills. Before we get started, make sure you have Visual Studio Code installed on your machine. If you haven't installed it yet, you can download it from the official website. Now that you've opened VS Code, let's start by creating a simple Java program that we will use for debugging. Let's break down this code snippet. We have a simple class named DebugExample with a main method which initializes two integers and adds them using the add method. To prepare for debugging, we need to create a launch configuration for this program. Open the Run and Debug panel from the sidebar, or press Ctrl+Shift+D on your keyboard. Next, click on the link that says Create a launch.json file, which will allow us to set up our debugging configuration. Choose Java as the environment. This will create a launch.json file in a hidden .scode folder in your workspace. The default configuration should look something like this. Here, we define the type as Java, give it a name, and specify the main class we want to run. Make sure the main class matches the class name where the main method resides. To start debugging our program, we can set breakpoints. A breakpoint is a marker that tells the debugger to pause execution at that point. Let's add a breakpoint on the line where the addition happens. Int c equals add a, b. You can add a breakpoint either by clicking on the left margin next to the line number or by placing the cursor on the line and pressing F9. Once we have our breakpoint set, let's initiate the debugging session. You can do this by clicking on the green Start Debugging button at the top of the sidebar, or simply pressing F5. Now, the debugger will launch, and the program will run until it hits the breakpoint. At this moment, the execution will pause, and you can inspect the current state. In the Debug panel, you'll notice a Variables section. Here, you can see the values of all variables in the current scope. For instance, you'll see that A holds the value 5, and B has the value 10. Additionally, there's a Watch section where you can add any variables or expressions you want to monitor closely. Let's add C to the watch list. After adding it, you will see C as an expression. However, since we haven't executed that line yet, it will show undefined. To continue the execution, you can press F5 again, or click on the Continue button in the debug controls. As the program runs to completion, when it reaches the line where we return the sum, the value of C changes from undefined to 15, since 5 plus 10 equals 15. Once your program completes, you'll see the output in the terminal. The output should read, sum, 15. This demonstrates how we can track and debug our code effectively. Now let's take it a step further and explore the step over, step into, and step out features. These features allow you to control the debugging flow more precisely. While you're paused at a breakpoint, if you want to execute the next line without stepping into functions, you can use the Step Over feature. Hit F10 to execute that line. This allows you to skip any method calls, effectively moving to the next line in the same scope. If we're interested in debugging inside the Add method, then we should use the Step Into feature. Press F11 to dive into the method call. This will take you directly into the Add function. Now you can step through the function line by line, observing how the local variables change. If you want to return from the current function back to the caller method, use Step Out by pressing Shift plus F11. Let's also discuss the Call Stack section in the Debug panel. This area shows you the path execution has taken, which can help you trace back through your function calls if something isn't working as expected. In the Call Stack, you'll see functions listed as you step deeper into your function calls. If you select any function in the call stack, you can jump to its code context and inspect values. In addition to using breakpoints, you can also use exceptions to catch bugs. In your launch configuration, launch.json, you can configure it to break on uncaught exceptions. To add this configuration, you can modify your launch.json like this. This configuration ensures that if an exception is thrown anywhere in your code, the debugger will pause execution, allowing you to check the context when the error occurs. So, let's modify our add method to introduce an error, for instance, a potential division by 0 error. With this error in place, rerun the debugger. If you pass 0 as the second argument in the main method, we should trigger the exception and see how the debugger reacts. After running this time, the debugger should catch the exception at the point where it occurs. You can click on the exception text in the call stack to see the call that led to the exception. As the program halts here, the Variables panel showcases relevant variables, enabling you to diagnose what occurred in your code leading to the error. We can also talk about conditional breakpoints. Sometimes, you might want your program to break only under certain conditions, instead of every time it reaches a specific line of code. You can add a conditional breakpoint by right-clicking on an existing breakpoint, the red dot, in the margin and selecting Edit Breakpoint. You can then enter an expression in the provided field. With this setup, the execution will only stop when both conditions are true, allowing you to minimize distractions and focus on significant states in your application. Lastly, remember to clean up any configurations you no longer need from your launch.json file to keep your workspace tidy. Before we wrap up, it's essential to mention additional debugging tools available in VS Code Extensions Marketplace that can enhance your debugging experience. Some popular debugging extensions you might want to explore include Java Test Runner, Code Runner, etc. Depending on your project type, you might find other tools that suit your development workflow. In conclusion, Visual Studio Code offers a robust set of debugging tools that can streamline your development process. By employing breakpoints, stepping through code, exceptions, and variable watches, you can efficiently identify and fix bugs. Make sure to practice these steps in your own coding environment to become more comfortable with debugging in VS Code. The more you practice, the more intuitive it will become. If you enjoyed this video or found it helpful, please give it a thumbs up. Don't forget to subscribe to our channel for more tutorials on Java programming and software development. Thanks for watching, and happy debugging!